Okay, let's get started. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London, so you might realize that I might be a little bit jet lagged because it's past my sleeping time already. But today I'm going to be talking about serverless with Knative. Before I start my talk, everything that I talk about here, the demos and the presentation, it's already on GitHub. So if you go to that GitHub link or the QR code, you can get access to all of this, right? And I also have a Twitter account in case you want to hear about Knative or cloud-native kind of technologies like Kubernetes and Istio. I tweet once in a while, but not that much. And then I already mentioned about Google Cloud for Startups program, so if you're interested, feel free to follow the link. So let's do an introduction to Knative. Knative, what is it? It's a Kubernetes-based open source building blocks for serverless. And then at this point, you might be surprised to hear this because when you think about Kubernetes, there's nothing serverless about it. Like Kubernetes, in Kubernetes, you have nodes, which are either virtual machines or physical machines, where you schedule containers. So there's nothing like serverless about it. But that's the point of Knative, is that it basically tries to give you the building blocks that enable you to do serverless on Kubernetes. When we think about serverless, let's first define what it means to be serverless. Depending on who you talk to, you get different definitions of serverless, but at least for me, when I think about serverless, there's like 4 pillars that I think about. First, as an application developer, you shouldn't really worry about the infrastructure. So the service that's behind Kubernetes or whatever the framework you're running on, it should be abstracted away from you, and it shouldn't be something that you should worry about. That's number one. The second thing is that you want the serverless framework to be idiomatic, meaning if you're a .NET developer, you want to use ASP.NET to build your web application. If you're a Java developer, you probably want to use Spring Boot. So whatever you're used to, you should be able to use that framework in your serverless framework. And then when you think about serverless, it's usually event-driven. So you're not really making synchronous calls, but rather your serverless function or your serverless container gets triggered by some kind of event. I mean, this event can still be an HTTP call, or this event can be a pops-up message, but it's an async event that triggers your serverless function, and then that triggers other things. And then finally, once you write your serverless function or container, ideally you take that and move it to different places. So just because you deployed it to Google Cloud, you shouldn't have to rewrite it to deploy it to Azure, right? So these are some of the pillars for me for serverless, and Knative kind of checks all these boxes, and we'll go through Knative, and hopefully you'll see that it actually plays pretty well with these pillars. Now, when we think about Kubernetes, who is here using Kubernetes or heard about Kubernetes? Okay, so most people. So I don't have to cover this in detail, but in Kubernetes world, you start with what's called a pod template. This is a definition of a single container or multiple containers that you want to be scheduled. Then you tell Kubernetes what you want to be true. In this case, we are saying replicas 3. So we want to run 3 copies of these containers. Then Kubernetes looks at the nodes that you have in your system. These can be virtual machines in the cloud or physical machines in your own system. And then it creates and schedules these pods. So the scheduling problem is now Kubernetes' problem, not your problem. And once your pods are running, you can have a service that exposes these pods. So this service will have a stable virtual IP, and people from outside will get to your service, and from there will get to your pods. So in this world, your microservice is basically a combination of your code in terms of a container image and the building blocks that Kubernetes provides. And when you look at developers, I mean, as a developer, like I don't really care about this, right? Like I want to write the application code and deploy that application code. So all these details, I mean, all these things that Kubernetes does is great, but it's not something that I should be worried about. So the application developers, they just want to write their code, and they don't really care about all the details of how the code is deployed and run. But at the same time, operators, they love Kubernetes, because it gives operators all these building blocks like replication controllers and services and pods and all the APIs, basically high-level APIs to run containers at scale. So there's this kind of tension between application developers and operators. And Knative kind of tries to solve this. Like Knative, it's basically a set of components called serving, eventing, and build that kind of gets installed on top of Kubernetes so that you can do serverless. So the application developers can do serverless, but the operators can still use Kubernetes and get the best of both worlds, basically. This started from Google. So we kind of like had internal systems where we learned about what kind of things that we need to do serverless workloads, and we basically gradually started open sourcing them. But now other companies like Red Hat, Pivotal, IBM, and many other companies, they're contributing. So it's an open source project on GitHub. Now the Knative stack, it kind of looks like this. First, at the bottom, you have Kubernetes as the platform where everything runs. Then on top of that, Knative relies on a gateway to do the routing, right? So for the gateway, it was mainly Istio up until recently. So it would use Istio for traffic management and all the traffic control features that you would expect from a gateway. But in the latest version of Knative 0.5, they also started supporting something called Glue. Anyone here used or heard of Glue? No, me neither. I never used it. But I think I know the reason why they started supporting another gateway. Istio as a gateway, it's great. It has a lot of features, but it's a little bit heavyweight, right? There's, for example, if you want to have a Istio-enabled Kubernetes cluster, you need to have at least 4 nodes. And there's a lot of features in Istio that you might not actually need. Glue, on the other hand, from what I heard, is much more lightweight. And that's why people started asking for it. And that's why it's supported in the latest version of Knative. But the thing about Glue is that if you want to use Glue as the gateway in Knative, it doesn't support Knative eventing yet. So you can only use Knative serving with Glue. So just keep that in mind. But anyway, so you have the Kubernetes as a platform. On top of that, you have the gateway, either Istio or Glue, managing the traffic. Then on top of that, you install the components of Knative, build, serving, and eventing that we'll take a look. And then the idea is that on top of Knative, you have other products that run. For example, Google Cloud Run. It's a managed serverless framework that we announced like a couple of weeks ago at Google Cloud Next. And then there's a version of Google Cloud Run that runs on GKE as well. These are built on top of Knative. And then other companies also, they're also building on top of Knative. So Knative tries to be the de facto standard for serverless on Kubernetes, but you wouldn't just take it and use it as it is. You would instead rely on other products that other companies are building on top of Knative. And today, I'm just going to talk about Knative as the open source project, and I will briefly also show you a demo of Cloud Run, the managed version of Knative on Google Cloud, so that you can see the developer experience on Google Cloud Run. By the way, I forgot to mention, my presentation is quite demo heavy from this point on. So if you're in the back, you might want to come closer if you want to see it. But I will also try to explain it here. So it's OK if you want to stay in the back. So what do you need to get a Knative stack? First, you need a Kubernetes cluster. In Google Cloud, you get a Kubernetes cluster either from the console or using the gcloud command line tool. So in this case, I'm just creating a cluster with 3 nodes in Europe. And then remember, Istio is a dependency of Knative, so you need to install Istio as well. So here, before I start installing Istio, I create what's called cluster role binding. This will enable Istio to manage my cluster. And then I install Istio. There's many different ways of installing Istio. You can ask Google Cloud to give you a Kubernetes cluster with Istio already installed. You can do that if you want. Or you can install Istio yourself. But here, I'm showing you how to do it yourself, because I want you to understand that Knative runs on any Kubernetes cluster. So I'm just showing you as if you're deploying it locally, basically. So you install Istio. And then after that, you can install Knative. So Knative has 3 components, serving, build, and eventing. You can install them one by one. You can install them all at once, or you can pick and choose what you want. In my case, I already installed them all at once. But it's basically up to you to decide which part of Knative you want. All right, so let me just switch back to my console. First, this is Google Cloud Console. And I have a Kubernetes cluster called Knative 0.5, which is for Knative 0.5 version. So I already created the cluster. I already installed Istio on top. And I already installed Knative components on top. So let's just make sure that everything is working. So if I do kubectl get pods, Knative eventing. So they had separate namespaces. I have the Knative eventing name pods running. Then let's look at serving. The serving pods are running as well. And then let's look at build. The build pods are running as well. So everything is running, and we're going to use this cluster to do our demos. Oops, sorry. So first, let's talk about Knative serving. So what is Knative serving? It basically enables you to take a container and deploy it in a serverless way. And what I mean by that is basically you just tell Knative, this is my container, and this is my configuration for my container. And Knative kind of figures out the rest of how to take the container, how to deploy it, how to set the routing to the container so that people can get to it. And then you also get features out of the box. So you get automatic scaling, meaning your container will run on a single pod at the beginning, but it will automatically scale up to n that you define. And it also scales down to 0. So if you don't use your container for, I think, 60 seconds or so, it will scale down to 0 as well. So you get that out of the box. Your service, your Knative service, will have a configuration. And every time you change the configuration, Knative creates a new revision. And then that revision, by default, will get the traffic. But you can also control that with traffic splitting. So you can set rules so that you can say this new version will get 20% of the traffic, or it will get 50% of the traffic. So basically, it enables you to go from a container to a service running on Kubernetes, where the traffic is already directed to that service, and where you have auto-scaling, and where you have configuration and revision and traffic splitting, right? That's what it is. There's some terminology with Knative serving. So first, you have a service. This service is not a Kubernetes service, by the way. It's a Knative service, so it's something different. So you create a service, and you define a configuration for the service. So the configuration includes the image that you want to point, and also the environment variables and things like that. And from the service and the configuration, Knative, when you deploy this, Knative will create a revision, and it will update the route to point to that revision. So this new revision will get all the traffic. Now, if you change something about the configuration, Knative will create a new revision, and it will update the route to that revision. So everything is updated by default. But as I mentioned, with traffic splitting, you can also change this route rules so that you can specify what part of traffic goes to which revision as well. So the service configuration, from there you get a revision, and from there you update the route. These are the primitives for Knative. So let me show you some of this in code. So I have this tutorial on GitHub I mentioned, and then in this tutorial I have the presentation, but I also show serving, eventing, and build. So I'm just going to refer to this as we go along. First, I want to show you a really basic example, hello world serving. So just deploy a service that just prints hello world, and let's see how you can do this with Knative. First, you need to create, in this case, I'm creating an ASP.NET Core web application. So you need to create that application, and then from there, you need to create a Docker image and push that Docker image to a public place. So I'm pushing it to Docker Hub. And then once I have my image in Docker Hub, I need to create a service file for my image, because I need to create a Knative service, right? So this Knative service, first thing you'll realize is that it's using the Knative API. So this service is not a Kubernetes service, but a Knative service. I give it a name. I define which namespace it belongs to. And then this is the configuration of my service. The first thing that you'll realize is that I'm saying run latest. So what this means is that when I deploy this service, route the traffic to this service. So all the traffic will go to this service. So that's what run latest means. And the configuration has the container. So I'm pointing to the container in Docker Hub. And I'm also passing an environment variable called target that says C# sample v1. So this target we're going to take in our code, and we're going to print it out. So we're going to say hello C# sample v1. So that's all we are doing here. So then you apply the service, and then in the end, what you get is you get the pods, the Knative service, the Knative configuration, the Knative revision, and the Knative route created for you. So let me actually do this. So I'm just going to copy this. So we are watching the pod Knative service configuration route. You will realize that I have some pods running. This is for some sample that I'm going to use later, so you can ignore them for now. But what I want to do here is that Let me go to serving and go to hello world C#. And then let's apply service v1. So now I'm creating the service. And then you'll see that immediately, make this bigger. Actually, let's not watch it because sometimes watch doesn't work, but let me just show you like this. So what you will realize is that first, Knative created a pod immediately for my service. Then it also created a Knative service for my service. Then it created a configuration for my service. It created a revision for my service that has the generation 1, meaning this is the first revision. And then it also created a route. So all the things that we talked about with Knative serving is already created. Now, to test this, as I mentioned, we have Istio for traffic management. And in Istio, there's something called Istio ingress that controls what comes into the cluster. So what you need to do is you need to find the Istio ingress's IP address, and then you need to curl it with the information about your service. So in this case, I'm curling the Istio ingress IP, but I'm saying that my host is hello world C#, that's the name of my host. It's in default namespace, and then this is the domain. And by default, there's an example.com domain that's used as an example. But you can also configure your own domain. So if you have your own domain, in my tutorial, I show you how to configure it. And I'm actually using something called nip.io. So nip.io, it's a dummy DNS that enables you to map URLs like this to IP addresses. So I'm basically using that to kind of have a domain for my dummy service without actually having to set a DNS. So I show all the details over here. I won't bore you with the details, but in the end, what we can do is basically do this. So if I come here, let me make sure that I have my Istio ingress set up. Yeah, I have my Istio ingress set up. And I'm just curling that Istio ingress IP, and I'm saying this is my service name, and it's in default namespace. So let's ping it. And if everything goes well, it should say hello world. Yeah, it says hello C# sample v1. So we deployed our container, and the traffic is going to that. As I mentioned, every time you change the configuration, Istio creates a new revision. For example, so yeah, we change the configuration, we get a new revision, and the traffic is routed to that. So for example, in this case, I have I have an update to my service, and here I'm using the same image, so I'm still using the same code, but the environment variable, I change it from version 1 to version 2, right? So I made a change to the configuration. If we do this, so let me apply this change. And then if I do get pods, it's a little bit hard to see here. Let me make this a little bit easier to see. And yeah, so what happened is that I applied the change, and then I have a new pod that's been created. Then the service is still the same service. The configuration is still the same configuration object, but I also have a new revision. So the generation is to create a new revision, and it also updated the route to point to the new revision. So if I do the same curl command again, you see that immediately I'm pointing to the new configuration. Now, let's imagine that you want to change your code. So you have new code and you want to deploy the code. It's pretty much the same thing. So in this case, what I'm doing here is that instead of saying hello something, I say bye something. So I create a new image out of this called v3, and I push this to Docker Hub. And now I come to my service definition, and I'm just changing the image from v1 to v3, right? And then I apply this change. So let's do that. And again, this will do the same thing. It will create a new revision immediately, generation 3. It will create the new pod. It will initialize it. And once the pod is running, if we do the same curl again, now we updated our code. We are pointing to the new code. So you can see that it's very easy to basically you just create an image, push it to somewhere public, and then just update your service definition file, and Knative takes care of all the other details. I mean, usually when you're in production, you don't just update your code and immediately set the traffic to it. You probably want to set some kind of traffic splitting so that you send maybe 5-10% of the traffic to this new revision and make sure that everything works before you upgrade. So you can do that in Knative as well. So in this case, I'm updating my service, and instead of doing run latest, I'm doing a release. So that's what Knative calls, right? I'm doing a release here, and then I'm saying these are my revisions, right? So this is the revision 1, this is the revision 4, and then there's something called rollout percent, 20, meaning 20%. So what this means, and it's a little bit confusing, is that this means that the first revision will get 80%, and the second one will get 20%. And the configuration here, it's the configuration for the second revision, right? So basically, this is an existing revision that you have. This is the new revision that you're going to create with this configuration. And this new revision will get 20% of the traffic. So that's what this means. So let's do this. Now I applied the version 5, F4. And if we look at version 4, so this is my service version 4, it's pointing to revision number 001 and 004. These revision numbers, they're not real actually, because if I look at my revision numbers here, the revision numbers, they have some hash code. So I need to actually replace them with the real revision numbers. So let me just copy this for the first one. So I copy that and replace this. And then for the fourth one, it's that one. Now I am actually working with the right revision, and let's apply it again. And by the way, you can see that some pod is terminating. The reason is because we haven't used the revision for a while, so it's scaling down to 0. That's the good thing about Knative, is that if something is not used, it scales down to 0. Okay, so we do this, and then let's just send some curl commands. So let me just copy this. Now I'm curling the same URL, but now I have two revisions, version 1 and version 4. Version 1 is getting 80% of the traffic, and at some point it should switch to now it's hitting version 4 and it's waking up. Now it's version 4. So as you can see, most of the time it's version 1, but some of the time it's version 4 that's getting. So that's how you can do traffic splitting. This is traffic splitting between an old revision and a new revision that you define here. Now, if you want to do traffic splitting between two existing revisions, you can basically just come to revisions and just point to two existing revisions. And in that case, the configuration will be ignored, right? So it will just look at this and it will just say, okay, these are the revisions that I know. I'll just do a 50% traffic splitting with these revisions. So that's how you can do that with existing revisions. The auto scaling in Knative is also configurable. So by default, this is what you get in Knative for auto scaling. So you get concurrency-based auto scaling, meaning each pod will get 100 requests, 100 in-flight requests per pod. But this 100 is configurable. And also the type of auto scaling is configurable as well. So instead of doing concurrency-based auto scaling, if you want to do CPU-based auto scaling, you can do it like this. And also the minimum and maximum scale, you can set them as well. So if you set min scale to 1, the Knative won't scale down to 0. And if you can set a max scale to 5, then it will only scale up to 5. So that's how you can configure auto scaling. All right. And you can also use Knative to integrate with more interesting things. For example, Twilio. Anyone here used or heard of Twilio? Okay, so many people. Twilio is a really cool product to basically write apps that respond to phone calls and SMS. So what you can do in Twilio, so this is my Twilio UK number. And this is Twilio console. And what you can do is that you can say, if I receive a voice call on this number, make a webhook call to this URL. In this case, this is just a Twilio demo URL. But then for messaging, if I receive an SMS, make a call to this URL. And this URL, it's basically pointing to my Knative service. So what I did is that I created basically an ASP.NET Core web application. And then in here, I'm using the Twilio libraries. And I'm saying that I have something called SMS controller. And this basically gets an SMS message. And when I get that message, I just respond back by saying the Knative copycat says, and just echo back the message, right? So I'm just basically receiving an SMS message and echoing back with the Knative copycat says. So I built an image just like before, and then I built a Knative service YAML file. So in the service YAML file, we are just basically pointing to the Twilio C# version, and then apply the service, and then we can test the service. So let's just actually do this. If I go here, so I'm just applying the service, and we should see that Twilio, a new service is created here, and a new pod is being initialized. And then here I have I'm looking at Android on the web. So these are my actual SMS messages on this phone. And this is my Twilio phone number. So in here, let's just send a message and say, hello from Minnesota at NDC. So I'm just sending a message to my Twilio number. And then this will basically, this message will go to Twilio. And then Twilio will make a webhook call to my Knative service, and the Knative service will reply back with the message. So that's how that goes. So let's see if it worked. Yeah, so I sent hello from Minnesota at NDC, and then the actual service said, the Knative copycat says, hello from Minnesota. So it's very simple, but it shows you that you can integrate with Knative with anything, really. All right. Now I want to talk about Cloud Run briefly. So everything that I talked about so far, it's all Knative and it's all on Kubernetes. So whenever you have Kubernetes running, either on Google Cloud or any other place, it will work. But we actually have a managed version of Knative, right? So we have Knative that's running everywhere. Then if you want to run Knative on Google Cloud, there's something called Google Cloud on GKE. It's basically Knative, parts of Knative that you can run on Google Kubernetes engine. And there's a fully managed version of Knative called Cloud Run that basically abstracts away even the Kubernetes part of Knative. So you can basically treat, it's like fully serverless basically, that you can even like forget about Kubernetes, the fact that there is Kubernetes, and just run it in a fully managed way. I actually just have a tutorial on this I just finished the other day. So let's just take a look at that. So one thing about Cloud Run is that it's only supported on US Central 1 region right now. So I have a separate project called Cloud. I have a separate project in US Central that I need to switch to. So let me just do that. So this switches my project to the right location. Then right now, Cloud Run only supports container images in Google Container Registry. So that's why here I'm pushing an image to Google Container Registries because I cannot use Docker Hub, right? So that's what this does. I already did this before, so I won't do it again. And then once you have the image in Google Container Registry, all you need to do is this. So let's just copy this. And gcloud, and it's beta, so we have to say beta, run deploy, and just point to your image, right? By doing this, it's asking me what's your service name. This is my service name. Now it's deploying the service, creating a revision, just like Knative, and routing traffic to that revision. So it's basically the Knative experience, but I didn't have to create a Kubernetes cluster. I didn't have to worry about installing Istio. I didn't have to worry about installing Knative components. Everything is done for me. I just get a fully managed version of it. And now I have my service. And if I actually go to my Google Cloud Console and go to Cloud Run, oh, actually, I need to switch my project. Go to my Cloud Run project, and then go here. Under Cloud Run, I see my service, and under here you can see that I have multiple revisions because I deployed this before, and I get a URL that I can click, and if you click, we will see the same thing, hello world v1, but now it's running on Google Cloud in a fully managed way. I just want to mention this because I think it's the right way of using Knative on Google Cloud because it's fully managed, and it's something that we just announced 2 weeks ago, so it's something that I wanted to mention here. Okay, let me switch back to my other project. All right, so that's Knative serving. Next, I want to talk about Knative eventing. So what is Knative eventing? It basically gives you the building blocks to connect event sources to event consumers with some kind of flow in the middle. That's what it is. It enables you to declaratively define your event sources and triggers and the services. And it works with like it works with messages that happens once in a while or streams of messages. But in the end, what you get is basically, no matter what you're reading, what kind of event source you're reading, you get cloud events in your services that you can use and process. These are the event sources that are supported. It's not the full list, but it's like the main ones. So you can read events from Kafka to your Knative service, from Google Cloud PubSub to your Knative service, GitHub events, and Google Cloud Storage events. The full list is here. But basically, the way it works is that there's something called a construct called source in Knative that kind of reads the external events. So let's say you're reading PubSub messages. These will read the PubSub messages. Then they feed that into something called broker. And then the broker will pass them to triggers where these messages might be filtered. And then eventually it ends up with a Knative service. So you're basically connecting the external messages to services running in Knative. And as I mentioned before, in the end, we convert all the different types of messages, external messages, into cloud events. This is an open source definition of events. And we are basically using those cloud events, do that conversion here, and pass those to broker. And from that point on, you're dealing with cloud events. And the broker, basically, it's just something that happens once per namespace. So you just enable broker injection to your namespace. And then you have a broker that kind of listens for external messages coming in. And then broker will pass those messages to what's called trigger. Trigger is basically the connection between the broker and the Knative service that you want to call. And then in the middle, the trigger can also do some basic filtering like this. But the filtering is really, really basic right now, but they're kind of building on top of that. So broker gets the message, and it passes to trigger, and the trigger does some very basic filtering, and then it will pass it to your Knative service. All right, let me show you an example of this. So go back to my tutorial. So we already talked about this, and we already have the eventing set up. So as I mentioned, you need to have a source that listens for the external messages and reads them, and then you need to have a broker that kind of gets the messages, the cloud events. I already created the source and the broker. In this case, I want to read messages from Google Cloud PubSub. So let's just double check that I actually have this set up. So if I go here, oops, sorry, kubectl get. So I already have a GCP PubSub source called testing source, and let's make sure that I already have a broker as well. So I have a default broker in my default namespace listening for the messages. So once you have this, you need to create a Knative service. In this case, the first example I'm going to show is really simple. We just want to get a message and just log it out. Just log it out, make sure that we can receive that message. So I have this ASP.NET Core application that will get the message, and it will just say, this is the message. You build an image just like before. You push the image to Docker Hub just like before. And then you create something called trigger.yaml. So this trigger.yaml has two purposes. First, it defines a Knative service. So this is my service called message.c#. And it points to my image. And I'm also setting the auto-scaling to 1 so that it doesn't scale down to 0. And then it also defines a trigger. So this trigger is basically the connection between my service and the broker. So it's basically pointing to my service and saying that this is the name of the service that I want to connect to. So I'm connecting the service to the broker. So let's apply this. I need to go to eventing and kubectl apply trigger. And then if we look at the pods, we should see that there's a message dumper that's already being initialized, and that's what we want to actually watch. So what I want to do is I want to look at the logs because it will log it out of this pod. So then you can see that it's waiting for messages. And now what I want to do is I want to trigger a message to Google Cloud PubSub. So we will send a message to Google Cloud PubSub topic From there, it will be ingested into Knative source. From the source, it will go to the broker. From the broker, it will go to trigger. And from the trigger, it will get to our service. So it's a long chain, but let's do it. So to send the message, we can use the gcloud command line tool. So here I'm saying gcloud PubSub topics, publish. The topic name is testing, and the message is hello world. Oh, I think I'm not in the right project, so let me switch back. Yeah, I want to do Knative. Okay, now it should be the right one. Okay, we send the message, and as you can see, immediately receive the message. This is the idea of the message. So the message was a Google Cloud PubSub message, but it got converted into a cloud event in the end. And this cloud event has an ID and the data. The data is the part that contains the actual message, and it's base64 encoded. So if we actually take this, and if I remember correctly, like this, you can see that when we decode it, we get hello world. So we got the message. It's not too exciting, but it shows you that that's how you make the connection from an external source to a service. Now, in the next example, I want to show you something more interesting. So let's imagine that you want to connect Google Cloud Storage to Vision API. So Google Cloud Storage, it's a place where you can store any kind of files. So what I want to do is that I want to create a bucket, and then I want to save an image to the bucket. And then what you can do is that you can enable notifications from the bucket. So when you save an image here, it will generate a PubSub message to a topic. And then from there, we can make Knative eventing listen that topic and receive that message that says this file was saved, and we'll pass that to Knative serving. And then Knative serving will call Vision API. Vision API is a machine learning API that you can use to analyze images. So what it will do is that it will call the Vision API with the image URL, and Vision API will extract the labels out of that image using machine learning, and then we'll log that out, right? So there's this whole flow, but basically what we are doing here is that we are connecting Google Cloud Storage, an event in Google Cloud Storage, and triggering a Vision API using Knative in the middle, right? So let's see what it takes to do that. I also have another example called Translation API, but we can skip that. It shows you how to do translation calls using Knative in the middle. So what I did is that, again, just create an ASP.NET Core web application. We will be receiving cloud events, so we need to parse those cloud events in our class. So that's the code for that, basically, to parse the cloud events. So then the cloud event will have different types. And in our case, when you save a file to cloud storage, the type of the event is called object finalized. So I'm basically looking at all the events, and if the event is if the event is not object finalized, I kind of don't do anything. Otherwise, I will process it. Then from the cloud event, I extract the bucket ID and the object ID, which will give me basically the URL where the image is. And then once I have the URL, I will create a Vision client. So this is a client that I will use to make the Vision API call. And I will just say detect labels async. So this will basically say extract the labels of this image using machine learning and give me the labels and give me max results 10. So I get max 10 labels out, and every label has a score depending on how confident the machine learning model is for the label. So I order by the score, and then I just log out the labels. So just like before, we create a Docker image and push it, and then we create a trigger. In the trigger, I point to my image. That's my service. Then I create a trigger that links my service to the broker, and then we'll just apply it. Before I apply it, this is how you enable notifications on the bucket. So this basically says, once you do something with the bucket, send a PubSub message to this topic, and then you can list the notifications like this, and then we can test out our service. So let's just apply this first. So I go Vision, kubectl apply. Oops, sorry, trigger. And let's check the log. So the vision is being initialized. And I want to check the logs again. So let's just copy the, yeah, so it's listening. And now what I want to do is go to Google Cloud Console. I am on Knative. Go to Cloud Storage. And there's a bucket called Knative bucket. This is where I set all this, I created and set the notifications. I'm going to upload a file. And let's upload this picture. I don't know if you can see, but basically it's a beach with a sunset. Open it. Now this is being uploaded to storage. Storage will trigger an event to PubSub topic. From the PubSub topic, we will go to a Knative source and broker, and from the broker it will go to the service, and the service will make a call to Vision API, and hopefully, if everything worked, yes. So we receive the content, so this is the cloud event, and then we made a call to Vision API, and then in the end, we get this that says the picture is labeled, sky, body of water, sea, nature, coast, water, so on and so forth. So that's how you can make a connection between two unrelated services using Knative serverless in the middle. All right, and the last thing that I want to talk about is Knative Build. But before I talk about it, let me start two builds in the background, and then as they're running, we can talk about Knative Build, and then I'll show you the end result afterwards. So let me go up, and under build, I have two builds. So in this build, I will build something. Let me just apply this first. I will build something and push to Google Container Registry. And in the second one, we're going to build something and push to Docker Hub. So we kicked them off, and now we can talk about build. So what is build? It basically enables you to go from source code to a container image in a repository. That's all there is to it. You can build like very complex pipelines using the YAML file and define multiple steps for your build. They can build containers and it can build other things as well. The good thing is that it basically enables you to build things within your cluster without you having to have Docker locally. There are some primitives with Knative Build. First is called build. It's basically a combination of one or more steps. So it can be a single step or it can be multiple steps, and it can be ordered as well. So you can define like steps in order. You can take a build and you can create what's called a build template out of it so that you can use it from multiple builds if you want. There's the notion of builders. For example, you can use a builder for the container, so to build a container image, but you can also have other builders for other things. And there's also service account. If you need to authenticate, you can create a service account and you can refer to the service account from your build so that things are authenticated. For example, when you want to push to Docker Hub, you need to be authenticated, so you need to be able to create a service account. So let me show you how builds look like in Knative. So in the Hello World build, what I do is I want to build a Docker image and push it to Google Container Registry. And one of the things about Google Container Registry is that you can push images anonymously if you want. You don't have to authenticate if you set it up correctly. So what I'm doing here is that I create a YAML file. And in this YAML file, the kind is a build. And this build has, first you need to refer to the source. So I'm just pointing to the Knative docs for the C# sample. And then you can have multiple steps here. You can have as many as you want, but I only have one step because I want to keep things simple. I'm using something called Canico. It's an open source project to build container images. So I'm using that, and I'm passing it some arguments. So I'm basically saying point to this Docker file and push to this destination. And in this case, the destination is gcr.io and my project name. So I'm basically pointing to my Google Container Registry area of my project. And it will basically build this sample and push it there. And how do you apply it? You basically just do kubectl apply, and this will give you a build object, and you can actually see a pod that will be initialized and run and do your build. And you can also look at the logs of the pod, just like any other pod. and see when your build is running. So let's just actually take a look, see if it's working. It takes a little bit of time. Actually, let's do it here. Yeah, so init state, they stay in init state until they're done. So it means that they're still running. But eventually, once they finish, they will build and push. In the meantime, I can talk about the Docker part. So this is Google Container Registry, but if you want to push to Docker Hub, it's a little bit more complicated because you need to authenticate. So what you need to do is first, you need to create what's called a secret. This is a Kubernetes construct. You create a base64 encoded username and password, and basically just create that as a secret in Kubernetes. Then you need to create a service account. This is also another Kubernetes construct that you point to your secret. So the service account kind of refers to the secret, and that's what you create here. And then you design the build just like before, but the only difference in this case is that I'm pointing to a service account. So this service account that I just created in Kubernetes, I can point to it, and then when Knative runs, it will use the service account to authenticate. And the rest of the stuff is pretty much the same. I'm just pushing to Docker instead of GCR, and I'm tagging it with Knative Build. So the rest is just the same. Let's just double check again. So they're still in init state, but I can actually show you if we go here, and if you go to Container Registry, under here, you can see that 2 weeks ago, I guess that's when I did this talk, there's an image with the tag Knative Build, so that's the build that was pushed by Knative. But once it finishes, it will have it here, but we don't have to wait for it here. Okay, yeah, I think that's all I had. So if you want to get the slides and the presentation and everything, you can go to GitHub, and this is the link as well. Knative has a new website, knative.dev, where they're moving from basically from GitHub to Knative site. You can watch that for the updates. And I think we have 10 more minutes, so if you have any questions, I'm here to answer them. Thanks very much.